Hello my friends, I hope you digested well the previous tutorial where we tackled this big but yet important tool of our data preprocessing toolkit. Indeed, now you know how to handle the case where you have some categorical data in your dataset, which is a situation you will encounter many times in your future machine learning career. And now we have two tools to cover. The first one being splitting the dataset into the training set and the test set, and the second one being feature scaling. So, before we start, I'm about to answer one of the most frequently asked questions in the data science community, which is, be ready for it, do we have to apply feature scaling before splitting the dataset into the training set and test set, or after? I've seen this question many times, and you will find that question in many forums of the data science community. Some people will say that we have to apply feature scaling before the split. Some people will say after the split. And now I'm about to reveal the right answer. There is only one right answer, which is, by the way, totally obvious after you get the explanation. So the answer is we have to apply feature scaling after splitting the dataset into the training set and the test set. And now, let me explain. So first, just to make sure everybody understands, let me explain the what first, and then I'll explain the why. So, of course, splitting the dataset into the training set and the test set consists of making two separate sets. One training set where you're going to train your machine learning model on existing observations, and one test set where you're going to evaluate the performance of your model on new observations. And it's important to understand that these new observations are exactly like, some future data that you're going to get and on which you're going to deploy your machine learning model. All right? So that's this first tool. And now, feature scaling simply consists of scaling all your variables, all your features actually, to make sure they all take values in the same scale. And we do this so as to prevent one feature to dominate the other, which therefore would be neglected by the machine learning model. All right, so that's the what for both of these tools. Now, let me explain the why we have to apply feature scaling after splitting the data set into the training set and the test set. It's really obvious. It is for the simple reason that the test set is supposed to be a brand new set on which you're going to evaluate your machine learning model. So it's exactly like, you're training your machine learning model on your training set, and then later on, after it is trained, you're going to deploy it on new observations. So what this means is that the test set is something you're not supposed to work with for the training. And feature scaling is, as you will see, a technique that will get the mean and the standard deviation of your feature, in order to perform the scaling. So if we apply feature scaling before the split, then it will actually get the mean and the standard deviation of all the values, including the ones in the test set. And since the test set is something you're not supposed to have, like some future data in production, well, applying feature scaling on the original data set before the split would cause some what we call information leakage on the test set. We would grab some information from the test set which we're not supposed to get because it is supposed to be new data with new observations. So remember this, the essential reason why you should not apply feature scaling before the split is to prevent information leakage on the test set which you're not supposed to have until the training is done. Alright, so I think I've explained enough. Now I'm relieved, and we're relieved that at least it's 100% clear for everyone. And so there you go, my friends. Let's implement one of the last tools of this data preprocessing toolkit, which is indeed the split of the dataset into the training set and the test set. All right, so how are we going to do this? Well, we're going to do it with a function by scikit-learn, the most popular and useful data science library, because once again this library contains a module that is called model selection, which contains itself a function called train test split. And this function will exactly do what we want, which is to create 4 separate sets, actually not 2 but 4, because we will actually create a pair of matrix of features and dependent variable for the training set and another pair of matrix of features and dependent variable for the test set. Alright, so we're basically going to get 4 sets: xtrain, which is the matrix of features of the training set, xtest, which is the matrix of features of the test set, ytrain, which is the dependent variable of the training set, and ytest, which is the dependent variable of the test set. That's exactly what we want. And now, why do we want this? Well, it's not us, it's actually the future machine learning model that we will build in the next part, which will be all of them expecting this format as input. For the training, it will expect xtrain and ytrain as input in a method actually called the fit method. And for the predictions, also called inference, these models will predict xtest. All right? So that's the reason. It is simply the format expected by the future machine learning models. And now let's get these 4 sets. So we're going to get them from scikit-learn, of course. There you go. From which we're going to get access to model selection. I really like Google Colab. And then from which we're going to import that train underscore test split function. Perfect. You see how we can be so efficient thanks to the assistance of Google Colab. I hope you really like it as well. All right, so now that we have this function, well, we're going to use it. And since we already know what this function will return, as I've just explained, well, let's create these 4 variables returned by this train test split function. And as we said, they are first xtrain, the matrix of features of the training set, therefore containing all the countries, one-hot encoded, ages and salaries of the training set. So xtrain, then xtest, the matrix of features of the test set, then ytrain, which is the dependent variable of the training set, meaning all the purchased decisions of the customers in the training set, ytrain, and then ytest, which same contains all the purchase decisions of the customers in the test set. All right? So that's the 4 variables returned by this train test split function. And since it is the function that returns this variable, well, let's take that function right away and let's add here an equals and train test split and then some parentheses. And now the question is, what do we have to input inside this function? All right, so actually there are some parameters that we can guess, right? Because indeed, this train test split is supposed to split something. So one of the input will be that something which we're about to split and which is, of course, our dataset. However, of course, this function does not expect the dataset as a whole. It expects, well, the combination of the matrix of features x and the dependent variable vector y. And that's the first 2 inputs of this function. So let's input them here. X first, the matrix of features, and y, the dependent variable vector. Great. Y, yes, then comma, and then next argument. So we still have to input 2 more arguments, which are going to be first the split size, because we're not going to split this data set into a training set and a test set of the same size. Actually, we need a lot of observations in a training set and a few in the test set, but we need a lot of them in a training set so as to give the future machine learning model more chance to understand and learn the correlations in the data set. So let me just tell you the recommended size of the split. Well, I recommend to have 80% observation in the training set and 20% in the test set. All right, this is a very good split, and therefore here we're going to input a new parameter which is test size, and we'll set that equal to 0.2, right? 20% observations will go into the test set. And therefore here, since we have 10 observations in this data set, that means that 8 observations will go into the training set, meaning 8 customers will go into the training set and 2 in the test set. And this is not necessarily the last 2, they will be taken randomly, but 8 of them will go into the training set and 2 in the test set. All right? And now we'll add one final argument just for teaching purposes so that we can have the same results displayed in here, in the notebook, because then I'm going to run some prints to show you these 4 elements returned by this train test split function, the training set and the test set. And since there are some random factors that are going to happen during this split, right, because the observations will be randomly split into the training set and the test set, well, to make sure we have the same random factors, we'll just add here random state equals 1, right? We're just fixing the seed here so that we'll get the same split, and therefore the same training set and same test set. All right? And that's it, right? This is the code to split the dataset into the training set and the test set. Let me zoom out a bit so that you can see it. All right, so that's the full code. This will return indeed these 4 new sets composed of the training set in X-train and Y-train and the test set in X-test and Y-test. Let me show you this right away. So we're going to add 4 new code cells here, right? And we're going to print each of these created sets. So first we're going to print X-train. Let me copy this. Then we're going to print X-test. Then we're going to print Y-train. And finally, we're going to print Y-test. Perfect. All right, so now let's execute everything, starting with this cell here, splitting the dataset into training set and test set. Done. Perfect. Run successfully. Now let's run the cell to print X-train. And as you can see, indeed, we have now 8 observations in this training set, right? 1, 2, 3, 4, 5, 6, 7, 8, which correspond to 8 customers taken randomly from this data set. And we clearly recognize the features here, with first the 3 columns being the one-hot encoded variables that encode the country categorical variable. We also call that dummy variables. Then we clearly have here the age as the second variable, as the second feature, and then the salary. So we clearly have a great matrix of features for the training set. All right, perfect. Now let's print X-test. So we'll get here 2 observations containing the same features here as here, right? This is the matrix of features still. So we have the dummy variables here in the first 3 columns, then the age and the 2 salaries of our 2 customers taken randomly from the dataset into this test set. Then Y-train, so here we'll get 8 purchased decisions, right, with the 0s and 1s here that were encoded before with label encoder. And of course, make sure to understand this. These 8 purchased decisions correspond, of course, to the 8 same customers of this matrix of features X-train of the training set, right? These features correspond to these purchase decisions. These are the same customers here. And finally, Y-test, which will output 2 results, meaning 2 purchase decisions, right? 0 and 1, corresponding, of course, to the same customers as in this matrix of features of the test set. All right, so there you go. Congratulations. Now you have a new tool in your data preprocessing toolkit, splitting the dataset into the training set and the test set. Not only you have this tool, but also you have the final answer to the ultimate question: do we have to apply feature scaling before or after the split? And it's clearly after the split to avoid indeed information leakage, because simply the test set is supposed to be something new, right? Something on which we evaluate our model on new observations. All right? Great. So I'm glad that you are really making progress here with new tools and new knowledge that actually reduce any kind of confusion. So now we're going to move on to our final tool, right? Feature scaling, which now must be applied after the split, and you will see what we'll get with some other prints after we deploy this tool on our dataset. So I can't wait to show this to you, and I can't wait to give you this last final tool in your toolkit, because then what does it mean? That means that we will be 100% ready to start building our future machine learning models.